Hey guys, I'm Sam, that's the Sun Eater, and this is a YouTube channel where we look at how to use batteries and solar to add range and utility onto old electric vehicles. Today's video is going to be on my progress on trying to separate the 12 volt power system in the Leaf from the high voltage battery and getting all the 12 volt loads to run off the solar powered battery bank in the back of the car. Now before I jump into the how I'm going about this, what leads I'm attaching where, and where I'm running wires through the car, I want to talk briefly about the why you would want to do this. It's not intuitively obvious to everybody why there's an advantage to removing the 12 volt loads from the vehicle's high voltage battery. And I like to make my videos beginner friendly, so I want to talk about a little bit about those 12 volt loads before I get started on the how I'm going about it. So if you already know why this was an advantageous modification, just go ahead and skip to this time in the video and that'll get right into the nuts and bolts of it. But for everyone else, let's take a quick look at why you would want to remove those 12 volt loads from the high voltage battery. What does that do for you? Why does that help? Well, every electric vehicle actually has two batteries in it. It's got the giant 600-pound, 400-volt lithium-ion battery that sits underneath the car, and it's also got this little 12-volt guy right here. Well, what do they need two batteries for? Well, when automotive engineers set about designing an electric car, they already had 12-volt like headlights and radio system. All the the electronic circuits of the car already existed from gas or ICE vehicles, and they didn't really need to reinvent the wheel and make, like, say, a motor for a windshield wiper that would operate at 400 volts, if that's even possible. So they have the big battery just run this motor right here, and the little battery runs pretty much everything else in the car, and it draws power from that large 400 volt battery pack under the car through this piece back here called the DC to DC converter. And you can see, it'll be tough to get on camera here, but you can see we've got these lines that come off of it. This one goes to the negative terminal of the battery, runs under there and attaches right here, and the positive terminal of the battery has one that goes back there to the DC to DC converter as well. And so this 12 volt battery that powers all those little electrical subsystems sucks power out of our big 400 volt battery that goes under there, and all those systems actually pull a pretty surprising amount of power. Our Leaf has a menu that we can go to that'll tell us how much energy those little subsystems are using. And you can see right there that right now we're pulling it around 200 to 250 watts with the car just sitting here parked in the driveway. If I go over here and turn the brights on, that jumps up to almost 500 watts. And you know, radio, other things, all those put a kind of parasitic load on that main battery that you use to drive with, the battery that gives you your range. So why do we want to separate the 12 volt battery from that main high voltage battery? Well, whenever your car is turned on, all these little systems in the car, even the little computer that runs it, is constantly siphoning that power out of your main high voltage battery. Now, 12 volt batteries are basically infinite in supply. We can replace those all day long and we'll never run out. But the high condition, good quality 400 volt batteries that go underneath the car that drive it, they're in short supply, and they're getting harder to come by every year as fewer and fewer new Leafs are sold. That's where pretty much all of these battery packs come from now. The new undegraded ones are from Leafs that drive off the lot and get totaled within like the first 10, 20, 30,000 miles. Those battery packs are removed from those old totaled ones and put in 10-year-old Leafs like the one I'm sitting in now that already have, 150,000 miles on them. And those new batteries give the Leafs a new lease on life. And we should absolutely continue to do that as long as those batteries are available, that's great. We can keep these electric vehicles on the road for a longer period of time at a very low cost. Fellow YouTuber Dala from Dala's EV Repair just did a video, I'll link it here, on how you can do one of these battery swaps for like $2,000 or something. And that $2,000 gets you a new battery, which gets you an extra, 50 to 100,000 miles of life on the vehicle, which is great. But as the sale of new Leafs kind of bottoms out and most people are expecting them to discontinue the line altogether within the next like 12 to 16 months, these batteries, the new high voltage batteries, are very finite in supply, and in the near future I think we can expect to run out of them altogether. So we have to make these things last as long as possible until somebody comes up with a aftermarket supply solution for the large 400 volt high voltage battery. So the question then becomes, how do we make the ones we have now last as long as possible? Well, damage is done to the batteries. Their lifespan is determined in cycles. And right now, as I sit here in this car, with it just parked in the driveway turned on, but anytime it's driving, anytime the vehicle's on, you are cycling that high voltage battery at a rate of 250 to 500 watts from all the 12 volt systems that are running. If we can separate that high voltage battery from the 12 voltage loads, and put those power those 12 volt loads with the 12 volt solar battery bank in the trunk, then we can reduce the cycle rate on our high voltage battery, make it last longer, and also give us a little bit more range. Your motor pulls like 20 to 30 kilowatt hours, or 20 to 30 kilowatts when you're just driving along the road at 55, 60 miles an hour or so. So the 250 to 500 watts that we'll be removing won't add a whole lot of range, but even if it's only a mile, I'll take it, even though the main goal of what we're working on today is separating those 12 volt loads in order to increase the longevity of that increasingly difficult to replace high voltage battery. So I hope all that illuminates to you the value to us as people who want to create like a sub $8,000, maybe even sub $6,000 EV, the value to us of removing those 12 volt loads from that high voltage battery. Hopefully all that illuminates it. Okay, let's take a look at how I'm going about doing this. So here is the system that I'm trying to build to disconnect the 12 volt loads from the high voltage battery on paper. Now, what normally happens is power comes in from the high voltage battery through the DC to DC converter to the 12 volt battery, and power just flows from the negative terminal through the loads back to the battery. That's your closed loop right there. But we've got, in this car, we've got our 12 volt battery bank in the back. Look at all that power right there. And that 12 volt battery bank is represented right here on the schematic. Now if we put a switch in between the negative supply from the 12 volt battery and the negative loads, and we connect that to the 12 volt solar, the negative terminal of the 12 volt solar battery bank, when that switch is open, power can no longer flow out of this 12 volt battery right here. And since that is an open circuit, all of this is an open circuit, and power can no longer flow through that DC to DC converter, or if it does, it just flows into a battery that doesn't have any power going in or out of it. So it basically just sits there, which is exactly what we want. We don't want power flowing through this circuit right here. So if this circuit is open, then how are our 12 volt loads getting powered? Well, power will come out of the negative terminal of our solar battery bank, flow through there, and even though there's a connection here, there's no power flowing really into or out of this battery, because this battery's on a open circuit through the 12 volt loads. It's just sitting there. So we can connect our positive terminal from our 12 volt solar battery bank to the positive terminal of this 12 volt battery, and it won't pull power out of here basically, because that's still an open circuit. So power flows out of the negative through there, back through there, and we have a closed circuit across our solar battery bank and an open circuit across our DC to DC inverter, which is exactly what we want. Okay, let's see what this schematic looks like when you actually build it. Well, we're gonna need 3 wires to run to the back of the car. One that's on the switch, one that connects the 12-volt loads to the negative, and one that connects the positive terminal to the positive terminal. That's 3 wires. So here they are. There's our wire right there that runs to the back of the vehicle from our positive terminal of our solar battery bank. This one goes to the negative terminal, and right down here I've separated the 12-volt loads, and you can see there is a 3rd wire right here, and all 3 of those wires run through a little hole that I've drilled in the firewall there. Through the hole I've drilled in the firewall, they come into the vehicle and run underneath the upholstery right here, and I've tucked the positive wire is inside the trim here. Here's our 2 negative wires. This switch right here is that switch right there on the schematic, and where these 2 lines connect right there, you can see the line coming from the solar battery bank in the trunk and from the 12 loads both connect right here, and that creates the option for us using this switch right here, where if something happens and we have several days where we're really just not getting any solar power, but we're still driving our car every day, and the power in this battery bank back here gets too low, well, we can close this switch right here and switch back to powering our 12-volt loads from our high voltage battery and continue to drive and operate the vehicle even if the power in this solar battery bank gets too low. And when you want to go back to running all the 12-volt loads off of the solar battery from your driver's seat, you can just open that switch right there, and voila. Past this point, it's just the 1 negative and 1 positive wire. Continue to run underneath the trim right here and connect to my 12-volt battery bank in the trunk right here at these terminal connections. Now, a pretty cool unintended consequence of having our DC to DC converter now connected directly to our inverter in the trunk is that, in theory, we should be able to operate this inverter from the main high voltage battery under the car, and in emergency situations, say like a power outage, we should now be able to operate the entire power supply of our 24 kilowatt hour battery through the inverter in the trunk, in theory. More on that later. Okay, I got our watt meter hooked up. I've done that like 5 times now, and it's still a pain in the butt every time. Okay, so source, that's hooked up to our wires that are going into the back of the vehicle here, connecting to the terminals of our solar battery bank in the back of the vehicle. The load, these we want attached to the 12-volt loads of the vehicle. So this one goes right here, and this one goes over here. I had to put a little extender to carry this down to the 12-volt loads, and you'll notice there is no connection on the negative terminal to the negative solar battery bank terminal right now. That's because I just want to make 100% sure that this is a open circuit and that any power going into those 12-volt loads could not possibly be coming from our HV battery, our high voltage battery, via our DC to DC converter. I want to make sure that all that power is coming from the solar battery bank in the back, so I broke that connection right there. These two were connected in the last shot. So here's where I got really confused, because if we look at our watt meter right there, we can clearly see a 0 watt power consumption. I know this meter works. I use this all the time to test batteries. It works great. It's very accurate. So if it tells me 0.0 watts, that's what's coming through there. But when we come and get inside the car, we find out, well, sure enough, Sam does have the car on, and I've got the brights on, and there she is cranking through about almost 500 watts. So where the heck is that 500 watts coming from? There's all of our 12 volt loads right here. That connects to the load sensor on our watt meter, as do the 12 volt positive loads. And the source, the power supply, is hooked up to those terminals in the back. I know it is because I flicked that, if I flick that little switch by the driver's seat and break this connection right here, the meter dies off. It loses power and it shuts down. So that is the hurdle that I am stuck at. I cannot for the life of me figure out what is powering the 12 volt loads on this car right now. It's clearly not the battery bank in the back, because that's running through this sensor right here and that would pick it up. And it's clearly not the car's original 12 volt system, because I've removed the 12 volt loads down there from, they used to have a setup here. Let me show you on the other car. This is what the negative terminal looks like originally from the factory with no modifications. And you can see all of our little wires that go to all of our 12 volt loads are over here. This big cable is obviously the power supply from the DC to DC converter. And I basically just disassembled this in the Sun Eater so that I could separate all those 12 volt loads from the 12 volt terminal of the battery, from the DC to DC converter. So yeah, that's all the 12 volt loads down there. I zip tied that little thing to the back of this little metal battery guide, and we know the power is not coming from the car. We know the power is not coming from the solar battery bank in the back, because that meter would be picking it up, and somehow the car is still powered up. So at this point you may be wondering, why make why make a video just to document how you can't figure something out? I did it because I feel like the method that I used is would be like the jumping off point for anybody who is trying to separate those 12 volt loads from the high voltage battery. And I can't for the life of me figure out what's going on circuit wise in there. I'm sure somebody will tell me, oh, just download the circuit diagram for the Leaf and look at it. Well, I'll see if I can put a few screenshots of what I've found online are up right here. And like, if you can look at this and it makes sense to you, great, congratulations. It may as well be written in Chinese to me. I can't make heads or tails of it. So I'm gonna reach out to some places that have a lot of experience making custom modifications on electric vehicles. I'm gonna reach out to Electrified Garage and a few other, Uncle Rich, and a few of the other people that are in this space, and pick their brains and see if they can maybe give me some insight on what it is that I'm not seeing, so that we can solve this problem. In the meantime, I've got plenty of other projects in the works. One thing that you may have noticed is that since these wires right here connect to our DC to DC inverter, and that connects to the inverter in the back of the car, we're pretty dang close to being able to access all the power in that high voltage battery from the inverter in the back, basically making this whole thing a power wall on wheels. We're pretty close to figuring that out. I get a little bit of voltage drop across those 4-gauge wires from the front to the back, but once I can figure out how to push the power through those lines at a slightly higher voltage, then we should be good to go as far as the turning your Leaf into a mobile power wall. Other projects I got working on, I've been ordering and slowly amassing a large collection of these old Leaf modules that I'm going to use hopefully this year, to build an off-grid solar power plant for the house. I did a video about 7 months ago that almost nobody watched on my plans to build a agrivoltaics, which is combining solar with agriculture, set up over my raised garden beds in the backyard, and that power is going to flow into a large power wall that's made out of these old Nissan Leaf battery modules. And of course, we're continuing still to work on a custom DC to DC step up that's going to take the power straight from our solar panels and convert it into 400 volt power that we can potentially run directly into the main battery, so we can bypass all that heavy expensive stuff that I've got in the trunk. If you guys saw my episode on connecting solar directly to the EV high voltage battery, then you saw my interview with James. He's still working on that, but my understanding is that he's hit a few snags, just like I'm hitting a few snags here. That's the nature of invention. It takes longer than you think it's going to, and you're gonna hit a bunch of hurdles and obstacles that you didn't see coming. But that's what we're gonna be working on in 2021. Speaking of the custom voltage step up, that was kind of a necessary component for the vehicle build that I wanted to do, where I put a whole bunch of batteries in the trailer behind the Leaf and use that custom step up to take the solar power and put it directly in there. Because getting our hands on that component is going to be way more difficult than we initially thought, and because the price of lightly used Leaf batteries has really been skyrocketing lately, I've got to be honest and say that that build just isn't possible for the foreseeable future. So I am gonna have to cancel my solar trailer Leaf giveaway. Everybody that was supported me in that and bought tickets for the giveaway and donated to it, all that money will have been refunded by the time you're watching this video. Something I still think I'll be able to make it happen maybe a couple years in the future, but at this time I just don't have the ability to get the components that I need to make it work. So that's where I'm at as far as separating the 12 volt system from the high voltage battery in the Leaf and what we've got coming up in 2021. Stay tuned. Thank you guys as always for the support, especially my Patreon sponsors. You guys rock. In fact, I've never done a giveaway on this channel. I want to do one today. So I got this solar backpack about a year ago with the intent of giving it away to somebody at the Earth Expo that got canceled because of COVID. So I'm going to figure out how to randomly select a list from the names of one of my patrons, and I'll insert that little video segment here of that process and getting selected, and one of the Patreon sponsors will win a solar backpack today. Okay, so I found this random name selector online, typed in the names of all my awesome Patreons. You can see the website in the top left-hand corner there. Spun the wheel, and the winner was Luke S. Thanks to all you guys for your support. Luke, reach out to me and let me know on Patreon, and let me know what mailing address you want this sent to. That's all I got for now. I'll see you guys in a couple weeks. Let's cut to an Economy View of the Week. Today's Economy View of the Week is located just outside of Seattle, Washington. Obviously it was involved in a crash, but the damage is mainly superficial. The vehicle still drives, and if you replace some body paneling and a couple airbags, then it's not in bad condition. The battery was replaced in 2015 and it's 86% state of health. That means that this Leaf has a range of about 70 miles at highway speeds and a battery capacity of about 20.6 kilowatt hours. The seller was asking $3,600, but I contacted him and he said he would do $3,400 for my viewers. That comes out to $165 per kilowatt hour for just the battery. That's not too far from what most people pay for just bulk batteries. So if you subtract the money that you would make from parting out the rest of the vehicle, I bet that the cost would come down to about $100 per kilowatt hour, which is about as good as it gets. Whether you repair the vehicle and drive it for years, or make some money parting it out, I still see a lot of value in this old Leaf. Alright, that's all I got for today, guys. Wish me luck in figuring out that 12 volt system mystery, and I'll see you soon.